So, imagine you're sitting in front of your computer, scrolling through social media, when suddenly you come across a post about quantum computing. You think to yourself, huh, that's neat, and keep scrolling. But what if I told you that quantum computing could potentially unlock the secrets of the universe? And no, I'm not talking about some sci fi movie plot, although, let's be honest, the TV show Devs did give us a tantalizing glimpse of what might be possible. Now, before you roll your eyes and click away, hear me out. We're not just talking about faster internet speeds or better encryption here. We're talking about the ability to simulate reality itself. Yeah, you heard that right. Simulate reality. Let that sink in for a moment. Quantum computers, unlike our everyday classical computers, operate on the principles of quantum mechanics. They can process information in ways that would make your smartphone's processor cry silicon tears of inadequacy. But here's where it gets really interesting. These quantum powerhouses could potentially simulate the behavior of particles and systems at the most fundamental level. Think about it this way. If we could accurately model every particle in a system, accounting for all their interactions and quantum weirdness, we could theoretically recreate any moment in time. It's like hitting the rewind button on the universe, but with the added bonus of being able to press play and see what happens next. Now, I know what you're thinking. But how can we possibly account for all the variables? There's just too much uncertainty. And you're right to a point, but here's where it gets really wild. Imagine you're flipping a coin. Simple enough, right? But now let's zoom in. We're not just talking about heads or tails anymore. We're talking about the exact angle of your thumb as it flicks the coin, the air resistance, the microscopic imperfections on the coin's surface, even the gravitational pull of the moon. Yeah, I said the moon. Don't laugh. In quantum mechanics, everything matters. A quantum computer could theoretically take all of these factors into account, running through countless simulations in the blink of an eye. But here's the kicker. It doesn't just spit out one result. It gives you a probability distribution of all possible outcomes. It's like Schrodinger's cat, but instead of just alive or dead, you've got alive, dead, breakdancing, and writing a novel about its existential crisis. Now, let's scale this up. Instead of a coin flip, we're talking about simulating entire moments in history. The quantum computer doesn't just give us one version of events. It gives us every possible version, weighted by probability. But here's where it gets really interesting. We can use known points in history as anchor points. Think about it like this. If we know for certain that event A happened and then event C happened, we can use our quantum simulation to figure out all the possible ways event B could have unfolded. The computer can filter out the impossible scenarios and narrow down the most likely chain of events. This is where the line between science and science fiction starts to blur. In theory, we could use this technology to reconstruct lost moments in history, to understand complex systems like the global economy or climate change, or even to predict future events with unprecedented accuracy. But let's not get ahead of ourselves. We're still talking about theoretical capabilities here. The quantum computers we have today are impressive, sure, but they're more like quantum calculators compared to the quantum supercomputers we'd need for this kind of simulation. Still, the potential is mind-boggling. Imagine being able to simulate the entire history of the universe, from the Big Bang to the formation of galaxies, to the evolution of life on Earth. We could potentially answer some of the biggest questions in science. How did life begin? Are we alone in the universe? What's the deal with dark matter? It's like having a cosmic cheat sheet, but instead of just the answers, we get to see all the work that went into them. But let's bring this down to Earth for a moment. How could this technology impact our everyday lives? Well, imagine you're trying to figure out why your friend is always grumpy on Tuesdays. With a quantum simulation, you could potentially model their behavior based on known variables. You know they always stop for coffee on their way to work, so that's one of your anchor points. The quantum computer runs through countless simulations, factoring in variables like traffic patterns, weather conditions, and even the barista's mood. It might determine that on Tuesdays, your friend's favorite coffee shop is understaffed, leading to longer wait times in colder coffee. This colder coffee makes them grumpy, which in turn affects their interactions throughout the day. Now, I know what you're thinking. Couldn't we figure that out without a quantum computer? Sure, maybe. But what if we scale this up to more complex systems, like predicting stock market trends or understanding the spread of diseases? Suddenly, we're not just talking about cold coffee anymore. The key here is the ability to resolve uncertainties. In our current models, we often have to make educated guesses or use averages when we don't have exact data. But a quantum simulation could potentially explore all possible scenarios simultaneously, filtering out the improbable ones based on known outcomes. It's like playing a game of chess where you can see every possible move and countermove before you even pick up a piece. Except instead of chess, we're talking about the game of life. And instead of just seeing a few moves ahead, we're potentially looking at the entire game, from the first move to checkmate. But here's where it gets really interesting. This technology could potentially help us understand the nature of free will and determinism. If we can simulate all possible outcomes based on initial conditions, does that mean our choices are predetermined, or does the inherent uncertainty in quantum mechanics leave room for free will? These are heavy questions, I know, but that's the beauty of this technology. It has the potential to revolutionize not just science and technology, but philosophy and our understanding of reality itself. Now, let's talk about some practical applications. Imagine being able to simulate the entire global climate system, accounting for every variable from the smallest ocean current to the largest atmospheric pattern. We could potentially predict weather patterns with unprecedented accuracy, helping us prepare for natural disasters and mitigate the effects of climate change. Or consider the field of medicine. We could simulate the effects of drugs on the human body at a molecular level, potentially revolutionizing drug discovery and personalized medicine. We might even be able to simulate the entire human brain, helping us understand consciousness and develop treatments for neurological disorders. But let's not forget about the fun stuff. Imagine video games with characters so realistic they have their own thoughts and motivations based on complex simulations of human psychology, or virtual reality experiences that are indistinguishable from the real world, where you could visit any place or time in history, interacting with simulated versions of historical figures. Of course, all of this is still theoretical. We're talking about computational power that's far beyond what we currently have. But the principles are there, and the potential is mind-boggling. Think about it. Every decision you make, every interaction you have, every random event that occurs, all of these could potentially be simulated and understood at a fundamental level. It's like having a crystal ball, but instead of vague prophecies, you're getting a probability distribution of possible futures based on quantum mechanics. And the best part? We could use this technology for both world-changing discoveries and everyday conveniences. Imagine never getting stuck in traffic again because your quantum-powered GPS can predict and route you around congestion before it even happens. Or how about weather forecasts, so accurate you'll never get caught in the rain without an umbrella again? We're talking about the kind of precision that would make your local weatherman obsolete. Sorry, Bob. But let's get really wild for a moment. Picture this. You're about to microwave some popcorn. You know that delicate balance between perfectly popped kernels and a smoky, burnt mess? Well, with quantum simulation, you could potentially calculate the exact time needed for optimal popping, based on factors like the moisture content of each kernel, the wattage of your microwave, and even the current atmospheric pressure. I know. You're probably thinking, do we really need a supercomputer to make popcorn? And you're right, it's a bit overkill. But that's the beauty of this technology. It could solve both the most complex problems facing humanity and the minor annoyances of everyday life. Let's scale it up a bit. Imagine city planners using quantum simulations to design the perfect urban layout, optimizing everything from traffic flow to green spaces, or economists using it to model global markets, predicting recessions before they happen and potentially preventing economic crises. The possibilities are endless, and frankly, a little mind-boggling. We're talking about a level of predictive power that borders on precognition. It's like having a time machine, but instead of physically traveling through time, we're simulating it with mind-bending accuracy. But here's where it gets really interesting. As we develop these technologies, we might start to uncover patterns and connections we never even knew existed. It's like when you're watching a complex TV show and suddenly all the seemingly random plot points start coming together in the final episode. Except in this case, the TV show is reality itself. And we're finally getting a glimpse of the grand unified theory of everything. It's like discovering that the universe runs on a cosmic version of JavaScript and we've just figured out how to read the code. But let's not get too carried away here. As mind-blowing as this technology could be, we've got some serious hurdles to overcome before we start simulating the entire universe on our laptops. For starters, the amount of computational power we'd need is staggering. We're talking about the kind of processing capability that would make today's supercomputers look like pocket calculators. And then there's the whole chaos theory thing. You know, the old butterfly flaps its wings in Brazil, causes a tornado in Texas deal. Turns out predicting complex systems isn't just about having all the data. It's about dealing with the fact that tiny changes can have massive, unpredictable consequences. Think about it like trying to predict the outcome of a group chat. You've got all these different personalities, each with their own moods, opinions, and tendency to send memes at inappropriate times. Now, imagine trying to simulate that chaos. You might know that Sarah always responds with a GIF, and Tom never reads the messages before replying, but throw in a wild card like a new pizza place opening up nearby, and suddenly all bets are off. One minute you're having a normal conversation about weekend plans, and the next thing you know, you're planning a group trip to Antarctica to see the penguins. And why? Because Jenny's cousin's roommate's dog walker mentioned that penguins are actually secret agents for an advanced underwater civilization, and now everyone's convinced they need to go investigate. This is the kind of butterfly effect we're dealing with when we talk about simulating reality. Sure, we might be able to predict simple systems with a high degree of accuracy, but throw in something as complex as human behavior, and suddenly our quantum simulation starts looking more like a quantum guessing game. But here's the thing. Even with these limitations, the potential applications are still mind-boggling. We might not be able to predict every single event with perfect accuracy, but we could potentially narrow down the range of possibilities, giving us insights we never had before. It's like having a weather forecast that doesn't just tell you there's a 30% chance of rain, but also gives you a detailed breakdown of all the factors that could lead to rain, from the movement of air masses to the evaporation rates of local bodies of water. You might not know for certain if you'll need an umbrella, but you'll have a much better understanding of why you might need one. And when it comes to more complex systems like the global economy or climate change, even a slight improvement in our predictive capabilities could have massive implications. We might not be able to foresee every stock market fluctuation, but we could potentially identify trends and patterns that were previously invisible to us. Of course, all of this raises some pretty heavy philosophical questions. If we can simulate reality with this level of detail, what does that mean for concepts like free will and determinism? Are our choices truly our own, or are they just the inevitable result of initial conditions and quantum probabilities? It's enough to make your head spin, right? But here's where it gets really interesting. Even if we could simulate every possible outcome, the act of observing those outcomes could potentially change them. It's like Schrodinger's cat, but instead of a cat in a box, it's the entire universe, and instead of just being alive or dead, it's in a superposition of every possible state. Talk about a cosmic identity crisis. But let's bring this down to a more relatable level. Imagine we could use our quantum simulation to predict whether you'll choose to eat a burrito for lunch tomorrow. We input all the relevant data, your eating habits, your schedule, the weather forecast, even the likelihood of your favorite burrito place having a special deal. The simulation runs, and it tells us there's a 92% chance you'll go for that delicious bean-filled tortilla wrap. Now here's where it gets tricky. If we tell you about this prediction, does that change the outcome? Maybe you're the rebellious type who'd choose a salad just to prove the simulation wrong. Or perhaps knowing that you're likely to choose a burrito makes you crave one even more. Suddenly, our act of observing the simulation has become part of the system we're trying to simulate. This is where the lines between free will and determinism start to blur. Are you freely choosing that burrito, or are you just following a predetermined path set by initial conditions and quantum probabilities? And if we can predict your choice with such accuracy, does that mean your decision was never really yours to begin with? But wait, it gets even weirder. What if the very act of simulating your decision creates a new timeline, a parallel universe where you do choose the burrito, while in this reality, you go for a pizza instead? We could be inadvertently creating a multiverse of lunch options every time we run a simulation. Now I know what you're thinking. It's just a burrito. Why are we making this so complicated? But that's the beauty of quantum mechanics. It takes something as simple as a lunch choice and turns it into a philosophical conundrum that would make Socrates choke on his souvlaki. And here's another mind bender for you. If we can simulate reality with such precision, could we be living in a simulation ourselves? Maybe our entire universe is just a quantum computation running on some cosmic supercomputer. For all we know, we could be characters in the most elaborate video game ever created, our every decision just lines of code in some higher dimensional being's quantum computer. It's enough to make you question everything, isn't it? But before you start pinching yourself to check if you're real, let's take a step back and consider what all this might mean for our future. As quantum computing technology advances, we might find ourselves on the brink of a new era of understanding. Imagine a world where we can simulate complex systems with such accuracy that we can predict and potentially prevent natural disasters, economic crises, and even personal conflicts. It's like having a crystal ball, but instead of vague prophecies, we're getting hard data and probability distributions. But here's the thing. With great power comes great responsibility, and also great confusion. As we unlock the secrets of the universe, we might find ourselves grappling with questions we never even thought to ask. Like, if we can simulate consciousness, does that mean we can create it? And if we can create it, what are the ethical implications? Are we playing God or just really good programmers? And let's not forget about the potential for misuse. In the wrong hands, this technology could be used to manipulate markets, influence elections, or even control people's thoughts. It's like having a cheat code for reality, and we all know how tempting it is to use cheat codes in video games. Suddenly, "I'm not addicted, I can stop anytime," takes on a whole new meaning when we're talking about simulating alternate realities. But let's not get too dystopian here. The potential benefits far outweigh the risks. We could be on the cusp of solving some of humanity's greatest challenges, climate change. We could simulate different solutions and find the most effective one. Incurable diseases. We might be able to simulate treatments at a molecular level and find cures we never even imagined. Traffic jams? Well, okay, maybe some problems are just too complex even for quantum computers. As we move forward into this brave new world of quantum simulation, we'll need to navigate a minefield of ethical, philosophical, and practical challenges. But isn't that what makes life interesting? We're not just pushing the boundaries of technology, we're expanding the limits of human understanding itself. So, the next time you're scrolling through your social media feed and you come across a post about quantum computing, don't just keep scrolling. Take a moment to marvel at the incredible journey we're on. We're not just observing the universe anymore, we're on the verge of simulating it, understanding it, and maybe even changing it. And who knows, maybe one day we'll be able to simulate the perfect social media algorithm that shows you exactly what you want to see, when you want to see it. No more endless scrolling through cat videos when you're looking for quantum physics memes, unless, of course, that's what you're into. In which case, may I suggest a simulation where cats explain quantum mechanics? Now, that's a universe I'd like to live in. But before we get too carried away with our quantum cat videos, let's take a moment to appreciate the sheer mind-bending awesomeness of what we're dealing with here. We're talking about technology that could potentially unravel the mysteries of the universe, answer the big questions about life, the universe, and everything. And no, the answer isn't just 42, and maybe even help us understand ourselves a little better. So, the next time you're faced with a tough decision, just remember, in some quantum simulation out there, you've already made every possible choice. And in at least one of them, you're probably a superhero, or a quantum physicist, or both. Now, if you'll excuse me, I need to go check if I'm in the right simulation. I ordered a universe with extra quark,